What's up, everyone? Let's start writing some SQL. This will be our first episode where we dive into the database. If you are not able to get to a screen like this, go check out episode 2, where we get set up in Hex and connected to the chocolate factory. So just to familiarize with what we see, Hex offers a nice, clean interface where we can write SQL statements inside of these SQL cells and then run them off to the database, right? Now, a really nice setup sort of helper step will be to show the database that we are working with. So if you click on the left side, and your screen will look probably something like this, you can now click on the chocolate factory. And if you open up this public folder, you'll see a list of the tables that are inside of the chocolate factory database, right? So these 10 tables right here. This is what we're going to be practicing on, and we can now get rolling checking out what's in these tables. So if I hit select star from ERP products, this is the most basic SQL command that you've probably seen before, and it's really useful for when you're exploring a data set that you're not familiar with, like this, right? So what we're doing is selecting everything, that's what this star means, is every column from the table ERP products. And so ERP products is a two-dimensional data structure up in the cloud. And when we run this query, Hex is going to go grab everything from that table. So you can run this query by hitting the plus button right here in the top right, or you can actually do Command Enter on your Mac or Control Enter on a Windows, and that will run the query as is. And voila, we have some data back from the cloud, and it looks like a list of products with a little bit of information. One thing I want to point out here is that Hex, when you're in this development environment, will automatically truncate to only 10 rows, right? And that's what's called preview mode. If you ever want to look at the larger list of results, you can switch over to this display mode, and it will pull the entire list of products, right? So in our database, it appears we have 13 products. In preview mode, which is all we'll really need for testing our queries, we are only seeing 10 of those rows. Now, the next step when you're pulling data and where SQL starts to really show what it's worth is that you can customize the way that this data comes back. And the first way that we'll commonly see changing data that comes back is something like a where clause or a filter. So this where clause allows you to pick columns like UOM and filter perhaps where they're equal to a certain thing. So I'm writing here where UOM equals grams, right? This is a hard-coded string, and so anytime you're using a hard-coded string in SQL, you're going to use single quotes or apostrophes around the text. And so now when I run this, SQL is going to only pull information that matches my request, right? And so this is just the first layer of how you can very customize, or you can extremely specifically request certain data from the database. So let's take what we've learned and do a quick practice problem. I want you guys to run 2 queries. First, look on the left side and find a work order number or a work order ID from the work orders table, and then use that to filter the complete logs table to show the results of that work order. All right, pause the screen now if you want to give that a go, and I will show the solution now. All right, so the first piece of this is just looking at the work orders table. So I can see on the left side of my screen, that table is called ERP underscore work orders. Not sure what happened there. So I'm running this, and Hex is going to return a list of work orders. Now, it's asking me to find one which is complete. So I need to use some context here and see that not all of these work orders have a complete timestamp. And so this work order, for example, is probably not complete. But let's take this first one and let's just copy this. So now what I can do is comment out perhaps my first query. If you want to comment anything to save it for later in SQL, all you need to do is dash dash, and this row is grayed out. It will not actually influence the query that you're writing. And what you can do now is select star from that complete logs table. So I'm looking for a table that looks like complete logs, MES complete logs. And I'm going to filter where the work order ID, right? So you can see if you just run this wide open, you'll get a nice view of which columns are in the MES complete logs. You can also click over here on the left side of the screen and you'll get a little view of the columns and their data types. And what I can do is where work order ID equals that number that I copied. And so here, when I run this, I'm now getting the data set that I was originally looking for, which is the complete logs for this specific work order, right? And now where we're headed is that it would probably be nice to sort this output, right? We want to show the complete logs in time order. And that's what we're going to pick up with. So let's say we want to pull less than every column, right? When we pull a table like this, ERP products, we don't necessarily need every column, and it can actually save some compute time with larger tables if we only pull specific columns. So maybe we don't care about the UOM today, right? What we can do, and what most SQL statements will end up looking like, is you'll add the names of the columns separated by commas. And so you'll start to see these types of structures. And when I run this, I'll get the exact same data set, only with my specific requested columns. Okay? And this is the correct format when you start creating queries that you want to share with others or you want to use in data visualization tools, because select star is really just an exploratory thing. It doesn't really communicate what you're pulling. So if somebody else is looking at the query, or even yourself is looking at the query in the future, it can be very confusing when you see select star. Versus when you read a query like this, you know exactly what you're pulling and exactly what you have to work with. Another pretty common pattern when you start to write SQL that's a little more laid out is renaming these columns. So ID might not always be the most helpful to someone who's just looking at this in an Excel spreadsheet, right? So what we can do is type as product ID. And so now we've done nothing to the data, but we've changed that column header and changed that label to make this data set much more clear to anyone who's going to be reading it. Okay, so we're selecting specific columns now and we're aliasing them. If you look at this data set, and if you look at the problem we just did above, the ordering isn't particularly helpful, right? So this table seems to be default sorted by product ID, but it'd probably be easier to look at if it was sorted in alphabetical order based on the English name. So what we can do is use an order by clause. So this is going to be the final row of any SQL query that you're working on, because SQL is transforming data into tables, and then the very last step will always be sorting that final output, right? So we can now sort by product name. So if we add this order by clause and we run our query again, we're going to get a similar data set, right? It's the same data, but it's now coming back sorted automatically. And we can very quickly, if for example we liked going from Z to A instead of A to Z, add DESC, short for descending, at the bottom of our, or at the end of our order by clause, right? And so we're starting to see the power of SQL, where we can very quickly and very specifically manipulate a data set to pull live data in a very specific format. And this is just the basics of what you can do, right? So keep that in mind, and let's do another practice problem. This time we're just going to need to access one table. So if you wouldn't mind, pause here and see if you can pull the current inventory levels sorted by quantity. Okay, so pretty straightforward. If you just take a look at the previous query, we are going to be looking for inventory levels. So if we look off on the left and we look for a table that might have the inventory levels, I think this ERP inventory summary is what we're going to be using. So let's do select star from ERP inventory summary, and let's just take a peek at that table. So I'm going to run select star anytime I'm exploring things, and I see an ID, a product ID that probably is related to which product is being measured in quantity, the quantity, and then the UOM, right? So anytime you're working with a business system like this, quantities are always going to have a UOM associated with them, and they always should. So if they don't, make sure that anytime you're using numerical values, there's a unit of measure associated with it. Could be in the column name, sometimes it's in an additional column like this, but make sure it's there. All right, and so what we want to do is order by the quantity. So we can see maybe which products have the most or the least quantity, right? And so now I can very easily start to order by in either direction. I can switch, maybe I only want to look for products that are measured in eaches. And so now I can very quickly, again, run that query and pull, okay, these are my highest inventory in eaches, and this is my lowest. So starting to pull useful information. Again, look at the speed with which we're able to manipulate and look at this data very differently. That's really where SQL starts to have its power. Okay. The final topic for today's video is going to be about calculations and applying formulas to the columns in these tables. So let's take a look at the MES complete logs table. So we've seen this a bit before. What we are seeing here is a log of when work orders have finished certain steps. Okay, so we'll get into this a bit more, but think of this as a job being finished. And each of these rows has a timestamp and a quantity. So what we can do, if we want to look at this data in a more specific way, we might want to do work order ID, timestamp, and quantity. And what we're going to start to see is we can do anything we want, just like in Excel, with these columns. So I can create a column here called quantity plus 10. I don't know why I would, but SQL is going to do that math for me, and it's going to change the outputted data. If I wanted to do quantity times 2, right? This data is going to come back very different. What this enables us to do is apply all sorts of functions well beyond just simple arithmetic to change the data that's coming back. So in this example, something that might bother some people and might be nice to automate is rounding this data. So we can see these numbers are coming back with all sorts of decimals. Let's go ahead and get rid of that by wrapping the quantity in a round function. And let's name this rounded quantity, just so nobody gets confused, right? So we can now see these numbers are all going to come back with 0 at the end of them, right? Now, hex is holding on to the data type, which is why hex is showing that decimal, but the numbers have all been rounded, and we can even do cool stuff like round to -2, right? And so this in SQL will usually do a pretty cool function, which is actually rounding to the hundredths place. And so now, if you're trying to aggregate high-level data, this can be a really nice way to summarize things quickly. Another one that can be really useful is maybe grouping these timestamps by week or by month is a nice way of getting set up for creating charts or doing aggregate analysis. So what we can do is use a function called extract, and let's get the week from timestamp. And so all this is saying is let's get the week from the timestamp as, and we'll call this week of year, right? So this is a common thing that you'll see in accounting and financial type analyses, but now we're getting the week of the year that timestamp occurred at, right? And it's automatically happening. Anytime I run this query, it's going to do the exact same function, even if the data changes, right? So we're applying logic in our code or in our query that can live forever no matter how the database changes. Okay? So let's take some of this stuff up here and do 2 final practice problems. So let's go ahead and pull the work orders table. You can pull every column, it's totally fine. And by looking at that, see if we can calculate the yield of the work orders. And so what I mean is the yield, if you are making 100 chocolate bars and the work order only produced 90 chocolate bars, that's going to be a 90% yield on that work order. So see if you can pull a list of work orders with a calculated column for the yield, and then maybe sort by yield and see which work orders have the highest and lowest yield. Okay, pause now. And let's get started. So I'm going to take you through my process, which would be to just do a quick look at ERP work orders. That's the table we're going to be looking at here. And I see a bunch of rows. I actually have to scroll, so I'm going to go ahead and just pick a few that I want. I want the ID, the original quantity, and the completed quantity, right? And so here I'm using a little bit of context to assume that the original quantity is what the work order was supposed to be for, and the completed was the actual. Okay, so let's format this in the cleaner way that you'll see most often with SQL. And right away, I notice in the problem that it says only completed work orders. So an easy way to get rid of all that will just be where completed quantity is greater than 0. And so now when I run this, I'm going to get only the work orders that have been completed. Okay? So the last piece of this will be creating the yield column. So based on what we learned above, we can do all sorts of arithmetic. In this case, we just need to do completed quantity divided by original quantity, and that will be a column called yield. Nice. So here we can see things are coming back. You can reformat this however you think is best. All answers would be acceptable here. Maybe we want to round this to 3 decimals and then multiply by 100. That's all okay. All of this is possible within SQL, and now we're seeing a very easy to read yield number that, if you want to take a look at your work orders, you might want to order by yield descending and get a good look at which work orders have the highest yield, and maybe you want to take a quick look at which work orders have the lowest yield and identify some potential issues that need to be resolved with these orders. Okay, last and final problem, let's just practice the other function that we talked about. Let's pull a list of MES completes in the month of August. So here we're going to be using a calculated column as a filter instead of as a column. Give it a go. All right, So again, we're going to start by just pulling the table, taking a look at what the data is, right? And so what we need to do is recognize that we can pull the month from this timestamp. So if I pull maybe just the ID, comma, work order ID, comma, timestamp, up above we learned this function called extract, and I can get the month from timestamp. And maybe we call this as month of, right? So when I run this, I'm getting a custom view of that table, and I believe the month of August will be the month 8, right? And so what we need to do is apply a filter that says where month of equals 8. When I run this, column month of does not exist. Okay, so this is an error one might expect. You have to actually run your filters on the data being pulled. Okay, so you can't filter on a column you're creating because the MES complete logs table does not have this month of. What you need to do is actually take that whole function that you're using up above, and you can apply that in your filter. And so now when I run this, I'm going to get a list of only MES completes where the month was August, right? Where it's month 8. Awesome. Great work. If you made it this far, appreciate you, and I'll see you in the next video.